we have multiplication of two binomials. Why? Because in the first parenthesis we have two terms and in the second parenthesis we have two terms. How we have to do? We have to multiply every term in the first parenthesis by every term in the second parenthesis. So this is equal. We will have a times this whole expression in parentheses 3a minus 3b, and next we have positive b times whole expression in parentheses, so 3a minus 3b. And now we have to use distributive law of multiplication, so we have to multiply every expression in the parentheses by a. We have to distribute a over each term in the binomial. So we have a times 3a, and next we have positive a. When we don't have sign, it's always positive times negative, so will give me negative, and we have a times 3b plus, and again we have to use distributive law of multiplication. We have to multiply every term in parentheses by b. In other words, we have to distribute b over each term in the binomial. So will be b times 3a minus b times 3b. Why I have negative sign here? Because positive times negative give me negative. And in the first expression we have positive b times positive 3a. That's why you have positive here. Now we always put first the number, next variable, and we have here only 3. A times 3a, so will be 3. We have to copy a times a, the same base, so we copy the base and we have to add exponents. When we don't have exponents, always invisible 1. So 1 plus 1 is 2. A times a is a squared minus a times 3b, so first number ab we have to copy, and next we have plus, we have b times 3b, so first we have to write the number, and next we have ba, and we will write variables in the alphabetic order, so will be a, b, minus b times 3b, so first number, b times b is b squared. We copy the base, when we have multiplication, we copy the base and we have to add exponents. When we don't have exponents, it's always invisible 1. So 1 plus 1 is 2. b times b is b squared. Now we have to combine the like terms. We have 3a squared and we don't have a squared. Next we have 3ab, negative 3ab, and positive 3ab. So we have the same number and the same variables, positive and negative, so this expression can cancel and it will be 0. So we have only 3a squared minus 3b squared. This is my solution. It was one way, and another way, much shorter. If you see these two expressions, in the second parenthesis we have 3a and 3b, so we can factorize 3. So let me copy this example one more time. We have a plus b times 3a minus 3b. So this is equal, like I said, we can factorize 3 from the second parenthesis, and we will put this 3 before this whole expression because we have multiplication, so we can do this. We have 3 from the second parenthesis, a plus b we will copy, and now in the second parenthesis we will have only a minus b. Why? 3 times a minus b, it will be 3 times a is 3a, 3 times negative b is negative 3b. Is the same what we have at the beginning. I only factorized 3 from the second parenthesis. And now we see that we have here formula for the difference of two perfect squares. When we have a minus or plus b, doesn't matter what we have, what we will put first, times a minus b, this is equal a square minus b square, difference of two perfect squares we have here. So we have to copy 3, and this expression is equal to that. So we have a square minus b square. And now we have to distribute 3 over each term in the binomial. So it will be 3 times a square minus 3 times b square. Why I have minus? Because we have positive 3. When we don't have sign, it's always positive, times negative give me negative. So we have negative sign. And 3 times b square is 3b square. We see that we got exactly the same what I have here. This way was much shorter. So if you remember this formula, you can always use this. This is my solution.